All right, guys. So we're looking, well, before we get started with today's assignment or work, is there any questions on the homework assignments? Now, what we're looking at today are composite functions, composition of functions. The composition of a function g with its function f is defined as f or g of f of x or f of g of x. Now, sometimes they're written as f of g of x, and it looks like fog, F-O-G. Now we have the other version of it, g of f, x, or golf. Now at this point here, I'm not going to be so much concerned about the domain and range and how they work with each other. We're just going to be focused on the composition of functions, these composite functions, because we plug one into the other. We start from the inside and work our way out. And the first one that we're going to look at is this one here. Let f of x equal x plus 2. Let g of x equals x squared plus 3. And find each composite. Now, I know it says f of g of x, but for this first one here, let's look at f of g of y. Hopefully make this make a little more sense. F of g of y. And we work from the inside out. So the first thing that we have is g of y. So in our function g of x, we're going to replace every x with y in its function. And if we do that, we're replacing x squared with y squared plus 3. Any questions on this so far? Now at this point here, we don't have f of x anymore. We have f of y squared plus 3. So we're going to replace this x with y squared plus 3 plus 2. Now at this point here, we can drop the parentheses, telling us that we have y squared plus 3 plus 2, which is y squared plus 5. So for us here, f of g of y is y squared plus 5. And that's it. Any questions on any of this here? Yeah, we could have left it as x, but I wanted to at least for us to see this here. Okay? So we kind of see how this works and how this operates, yes? Any questions on this here? We good with this here? Okay. Now, exactly, we could leave it as x, g of f of x. And for the first one here, so for f of x, well, essentially we're going to replace every x in f of x with x, which just gives us just the exact same function. So it really doesn't make a difference. It doesn't change anything. But for g of x, well, I don't have g of x anymore. I have g of x plus 2. So that means every x in g of x is now going to be replaced with x plus 2, which will tell us that we have x plus 2 squared plus 3. Any questions on this here? Now we can simplify this, because we have x plus 2 times x plus 2 plus 3. Well, our x plus 2 times x plus 2, we can distribute the x. X times x is x squared. X times 2 is going to be 2x. We do the same thing with 2. 2 times x is going to be plus 2x. And lastly, 2 times 2 is plus 4 plus 3. Which tells us that we have x squared, well, the 2x plus 2x gives us 4x. And 4 plus 3 is 7. Telling us that g of f of x is x squared plus 4x plus 7. Any questions on any of this here? Any questions on anything we've done so far? Are we good with these here? Okay. Let's look at the next one. We're going to find f of g of x. So at this point here, we can plug g of x in its place, because g of x, we're just replacing x for x, so we're really just plugging in 2x minus 4 in place of g of x. We're plugging x in place of x. Doesn't really change anything, so we're just now having f of 2x minus 4. Now, we're going to replace every x in f of x with 2x minus 4. So what that gives us is the cubed root of, well, we don't have x anymore. We have 2x minus 4 plus 1. We can drop the parentheses, telling us that we have the cubed root of 2x minus 4 plus 1, which is telling us that we have the cubed root of 2x minus 3. So f of g of x is the cubed root of 2x minus 3. That's it. Questions on these composite functions? What do we think of the composite function so far? It's not too bad. We just take it one part at a time. We go inside out. Because if we try to do more than that, they get a little complicated. But as long as we take it one part at a time, they're not too bad. Now, if we look at this one here going the other direction, g of f of x, well, the first thing we need to do is plug x into f of x, or really just replace f of x with its function, cubed root of x plus 1. And at this point here, now we're replacing every x in g of x with the cubed root of x plus 1. So we have 2 parentheses, cubed root of x plus 1 minus 4. Now we can multiply those two. 2 times cubed root of x plus 1 minus 4. That's as far as it actually goes, because we can't simplify it any further from there. Any questions on any of this here? Is f of g of x or g of f of x here the same thing? Do we get the same value or same equation? No. Because f of g of x on the last one was the cubed root of 2x minus 3. These two here are vastly different equations. Any questions on any of this here? We ready for the next one? Do we need to see another example of finding these composition functions? Do we feel comfortable with doing these? Yes? We all awake? If we feel good with these here, we'll go to the next type. Let f of x be 3x minus 4 and g of x be x squared plus 2. We want to find f of g of 3. F of g of 3. Now this time, instead of having x, having a variable, we have a number. So we're going to plug 3 into g of x. So that would give us 3 squared plus 2. Now at this point here, we can plug all of that into f of x. I would advise against it. And the reason I would advise against it is if we plug this in, we'd have 3 times 3 squared plus 2 minus 4. And that is a lot there. So there's nothing wrong with doing that. I would just simplify what we have so far. Because at this point, we could do 3 squared plus 2 in a calculator. It would have no issue with that. We could do it by hand. Well, 3 squared is 9, and 9 plus 2 is 11. Because in a calculator, I could say 3 squared plus 2 is 11. So we have f of 11. Now we just plug 11 into our other function. So we say 3 times 11 minus 4. And this here should, I think, looks a little bit nicer than what we had previous of having 3 times 3 squared plus 2 minus 4. And again, we could type this into a calculator. It would give us our answer. If we did it by hand, it would be 33 minus 4, which is 29. Telling us that f of g of 3 is 29. And that's it. Questions on this here? Questions on any of this so far? Now we're going to look at g of f of negative 1. G of f of negative 1. Now for this first part, we're going to plug negative 1 into every x in f of x. So that would give us 3 times negative 1 minus 4. And most likely at this point, you'd plug all this into the calculator, let it do it for you. So let's say 3 times negative 1 minus 4 is negative 7. And again, at this point, now we're going to plug negative 7 into every x in g of x. So that'd be negative 7 squared plus 2. And again, we can plug this into the calculator. Parentheses, negative 7 squared plus 2, enter, is 51. So our answer for g of f of negative 1 is 51. Any questions on any of this here? Any questions on these here so far? So we'll do one more of these here. Now we need to plug 1 into g of x. So we have the absolute value of 1 plus 5. F of the absolute value of 1 plus 5. Now we can plug these into the graphing calculator if we want to. Because the graphing calculator, if I can put math over 1 to number ABS at the top, lets us do absolute values. So absolute value of 1 plus 5 is 6. Yes. Because the absolute value of 1 is just 1, plus 5 is 6. Now we plug 6 into every x in f of x. So we have negative 2 times 6 plus 3. And again, we can plug this straight into the calculator, and it would tell us that it is negative 9. 2 times 6 plus 3 is any questions on any of this here? Do we need to see another example of one of these? So this here is the last thing we're going to do. We're not going to worry so much about the domain and range on this, or the domain, but I do want to find the composition of each one of these here. So the first one we're looking at is f of g of x. And again, for these here, we're going to plug in g of x function for g of x. So we're replacing g of x with 2x minus 4. So replace g of x with 2x minus 4. And now we have f of 2x minus 4, so in every place where x appears in f of x, we're going to replace it with 2x minus 4. Which gives us 2x minus 4 to the negative 1. And this is it. This is as far as we're going to take this here. I will take this as your final answer. Because realistically, we can't leave an exponent negative. We'd have to move it from the numerator to the denominator, the top of the fraction to the bottom. But we'll take it as this here. So for us here, f of g of x is 2x minus 4 to the negative 1. Questions on any of this here? Let's look at the next one. G of f of x. And this time we're going to replace f of x with its function, which is x to the negative 1. And again, just like before, we're going to take what's inside here, x to the negative 1, and every x in g of x is going to be replaced with it. So up 2 times x to the negative 1 minus 4. Well, that's just 2x to the negative 1 minus 4. Is our g of f of x. Any questions over any of this here? Do we feel good with these here? Yes. It looks like that's it, is it? Because I don't think this is posted up there. Okay. I'm going to let y'all use the rest of it. Well, let's look at one last thing. I want to pick two functions. Let's say f of x is 3x minus 4. And g of x is so let's look at the function f of g of x. And again, just like we've been doing, we'll take g of x and replace it. So we'll have f of x plus 4 all over 3. And what do? We take this and replace every x in f of x with it. So we'll have 3 times x plus 4 divided by 3 minus 4. Well, some of this will simplify, because if we multiply that fraction by 3, what's going to happen? The 3 and 3 would cancel out, yes? So you just x plus 4 minus 4, which is just x. Okay. Now let's look at g of f of x. So again, just like the previous one, we'll replace f of x with its function, giving us g of 3x minus 4. Then at this point here, we plug 3x minus 4 into g of x's x values. There's 4 plus 4 all over 3. Which is really saying that we have 3x minus 4 plus 4 divided by 3. Well, our plus 4 and minus 4 cancel out, giving us 3x divided by 3, which is x. Well, this is the first one where they're the exact same, yes? And we'll delve more into this not tomorrow, but Monday when we start talking about inverses. Now, something else that I find that's kind of interesting with this is if we looked at, say, f of g of 8, let's see what value we get. So we can plug 8 into g of x, which would be 8 plus 4 divided by 3. We can do that in a calculator. Fraction 8 plus 4 divided by 3, which is 4. So f of 4, I just picked 8 randomly. I didn't actually check to see if that would actually simplify nicely. But now we can plug 4 into f of x. I actually didn't know what the answer was before we were starting this. Because 3 times 4 is? 12 minus 4 is? I'm going to go back. Now our composite function told us what? F of g of x was what? F of g of x is? So it gives us the value. F of g of x is x. So whatever value this is for these functions is what's going to come out in the end. But if they're not x, it doesn't equal x, it's not going to work out that way. That's why all the values, or the ones we had previous, the number that we plugged in was different than the number we got out.